Thank you very much for being here. I am Paolo Patierno. I am a software engineer working on Red Hat on the messaging and data streaming team, so mostly working on Apache Kafka and even on Strimzi, that this is what we are going to talk about, which is a CNCF incubating project, and it's about running Kafka on Kubernetes. I'm one of the core maintainers, and with me there is Tina.
Hi everyone, my name is Gantigmaa Selenge, but I usually go by Tina, so I'm a software engineer at Red Hat as well, and I also contribute to Strimzi and Kafka as well. All right, so agenda for this session, we will start with introducing Kafka and Strimzi, so don't worry if you don't know too much about them. And we'll also talk about some of the new features that came to Strimzi, such as KRaft, tiered storage, and auto rebalancing. And we will also talk about some of the exciting upcoming features. So what is Apache Kafka? It's a leading distributed event streaming platform. It scales horizontally and it's highly available and fault tolerant, and it has a wide variety of use cases. It can capture data in real time from various sources, data sources like database, event-driven applications, or other cloud services, and store that durably to be consumed by other systems to manipulate or react to them in real time. So it was originally created by LinkedIn and open sourced under Apache Software Foundation. It's licensed under Apache License 2.0. So what is Strimzi? So it's also open source project. It's CNCF incubating project, as Paolo already mentioned. It's also licensed under Apache License 2.0. So Kafka sounds great in terms of what it can offer, but it is operationally very complex. That's why running Kafka on Kubernetes become very popular. It was probably the most popular way to run Kafka. However, even that represents its own challenges, because Kubernetes doesn't have that necessary Kafka-specific knowledge to keep that availability and performance. So Strimzi manages Apache Kafka on Kubernetes, as I said. It's based on Kubernetes operator pattern, and it provides various operators for running and managing Kafka components. And it massively reduces operational overhead. So Strimzi really allows you to run Kafka in a Kubernetes native way. It uses the CRDs to extend Kubernetes API to define Kafka resources. And integrates that Kafka knowledge into the operator, and that is really important when it comes to doing upgrades and rolling updates. And also manages Kafka resources through the operator pattern as well, like Kafka topics, Kafka users, and connectors. Right, so Strimzi automates the installation of Kafka, as well as its other Kafka components, such as Kafka Connect, which lets you connect your cluster to various external systems, and also Maker, which allows you to replicate your cluster for disaster recovery, and also HTTP Bridge, which is provided by Strimzi for connecting to your cluster over HTTP. And there's Zookeeper as well, but I'll come to that in a bit. So Strimzi handles not just day one operation, also day two operations, such as upgrades, certificate management, scaling of clusters, and configuration of clusters, and also uses another open source project called Cruise Control to balance data in your cluster. It also lets you monitor your cluster easily. It integrates with various different monitoring systems. So there's also a new project that was added recently called Metrics Reporter, which allows you to expose Kafka metrics directly to Prometheus without using JMX. Also offers various authentication mechanisms, and it integrates really well with other CNCF projects like OpenTelemetry, Prometheus, and KEDA. Okay, so we'll move on to the recent features of Strimzi. So we'll start with KRaft. So KRaft, it removes Zookeeper dependency of metadata management. It was used to store the metadata of clusters before, and it's being replaced by Kafka's own implementation based on Raft protocol. And this simplifies the deployment and management of the clusters because you have a single system to manage and operate. And also it improves the scalability because Kafka is very, very scalable, and Zookeeper tends to have a limit when it comes to scaling. And it makes it much more efficient and performant because you don't have to sync the metadata between Zookeeper and Kafka. So this is how Zookeeper-based clusters look like. So you have brokers, Kafka broker nodes, and then you have your Zookeeper cluster. And one of those broker nodes designated as a controller, and then used to talk to Zookeeper to coordinate all the metadata updates. And this is now how KRaft cluster looks like. You just have only Kafka nodes. Some of it is serving as controllers, and some of it is serving as brokers. So those controller nodes, they form a quorum based on the Raft protocol. And it's basically distributed quorum where a metadata topic is stored locally in each controller node. And one of the controller node is the quorum leader, and it's called active controller. And then the other controller, so that active controller is handling all the partition assignments and updates to the metadata topic. And then all the other controllers are just following and replicating that metadata topic updates. And it's just trying to keep up to date. So brokers also store this metadata topic locally. And then they talk to, they talk to the active controller to coordinate the metadata, to get the metadata updates. And a couple of slides before with the Zookeeper cluster, you saw that one of the broker used to be designated as the controller. So none of the brokers controller needs to, the broker nodes need to do that anymore. They just handle the client topic data. And then it's the controller, active controller handling all the partition assignments and the coordination of that metadata. So with KRaft also it offers various different ways you can run the cluster. So the usual setup is having designated broker nodes and having designated controller nodes. And this is great for large clusters, and this is the recommended setup for production. And also allows much better scalability. But you can also run it in combined mode, meaning that some or all of your controllers, some or all of your nodes serving as both controller and brokers. And obviously this saves you some resource because you can run much less count of nodes. But you need to be aware that if a node is serving as both controller and broker, it might need more memory and CPU resource. You can even run single node cluster if you need a cluster that, if you need to spin up cluster very quickly for just some testing purpose, this works great. So the last three setup is really just for development environments. So of course you can migrate your existing Zookeeper-based clusters to KRaft. And the migration process is quite complex and manual, but Strimzi supports it and it allows you to do it in a semi-automatic way. It's driven by users through annotations. It couldn't be fully automated because of the significant difference in the architecture and configuration. However, by giving back some of that control back to the user, it allows you to have the rollback option. So the migration is done in phases, and then up until the last phase, you can roll back to Zookeeper. Right, so KRaft was announced in 2019, so it's more than 5 years ago. And then it was first supported in Strimzi 0.29 as an experimental support. And it was enabled by default in Strimzi 0.40, so meaning all the new clusters that were provisioned after this version, they will be running in KRaft mode by default. And then just 2 weeks ago, Kafka 4.0 was released, removing Zookeeper completely. So we're very happy to see finally this KRaft feature is coming to completion. And now we're working towards Strimzi 0.46. So the current version is 0.45 and supports Kafka 3.8.0 and 3.9.0. And it's the last version with Zookeeper support. And we plan to provide extended support for this version, probably around a year. And so this is the last chance you can migrate your existing Zookeeper-based clusters to KRaft. Because with Strimzi 4.6.0, which is the next release, it will only support KRaft mode. It will support Kafka 3.9.0 and 4.0. And we're also using this opportunity to remove some of the deprecated components like Mirror Maker 1. Okay, so if you'd like to learn more about KRaft, here is the link. And with that, I think I'll pass to my colleague.
Yeah, thank you, Tina. So KRaft was one of the big features that was added to Kafka. So now we are supporting that since a long time in Strimzi, and with Kafka 4 and Strimzi 0.46 that we expect to have within maybe this month. You will have KRaft as the first choice, or the only choice for running your Kafka cluster. So it's not just about KRaft as the main features that we have today within Strimzi, but even the tier storage. Even tier storage is something that was added in Kafka itself. So with tier storage, you can think of offloading some messages, so having some maybe old messages got from your brokers to be offloaded on some other storage, like, for example, could be a cloud storage like Amazon S3 or things like that, Azure Blob Storage and so on. So why you should use the tier storage? First of all, so there are several reasons, right? First of all, for cost efficiency. So it means that you have on your brokers, of course, disks that maybe are more expensive because you want performance, you can run with SSD and things like that. And of course, in this case, if you are going instead to offload all the messages, so messages that are part of the history of your Kafka cluster that you want to have there anyway, but they are not read so often by the consumers, you can just offload these messages in some more cheaper storage that could be something in the cloud, and having the more up-to-date data still on the brokers. So you can have less disk space used on the brokers and offloading something on more, cheaper storage and so on. So the first reason is the cost, which brings, of course, scalability as well, because you have the computation mostly running on the brokers and storing there the messages that you are accessed frequently, and maybe the older ones on the cheaper storage. But it's also really useful for faster recovery and rebalancing. About faster recovery, you can think that when something bad happens, for example, on a broker, and you are restarting the broker has kind of to recover the data, reconstructing the log. Of course, more data you have on the broker, more the log are bigger in size, you have more segments in the logs, then it will take more time for the broker to reconstructing everything. So in this case, of course, if you are offloading older messages somewhere else, you can be faster when recovering from the brokers. And even on rebalancing. Rebalancing, as Tina mentioned before, there is the usage of cruise control, for example, where rebalancing means moving partitions across your cluster, across all the brokers within your cluster, in order to have a more balanced load across all of them. But of course, if you are moving partitions which are little in size, you can be faster on rebalancing. So again, you have the older data in other storage, in the cloud storage, for example, then you can just rebalancing your cluster with less partitions and less data. And last but not least, simplified cluster operations. It means that, for example, you don't have to deal with disk expansions because you are getting more data, so you need to expand the disk on your brokers. You are just writing the old data on the cloud storage, and then you don't need to run this kind of operation. Or, for example, deleting old segments because they are getting bigger and bigger and bigger. So these are the one main reason that you should use tier storage within Kafka. Of course, with Strimzi, you have a Kubernetes approach, as usual. So within our Kafka custom resource, which is the main custom resource that you use today for deploying a Kafka cluster with Strimzi, there is a new field, which is the tier storage field, where you can specify the implementation of the remote storage manager that you are going to use. So in Kafka, you can even write your own storage manager. You have to implement some interfaces. You can build this jar and baking your image, the Kafka image, starting with from the Strimzi one, to have this plugin inside, and then you can apply the configuration here for your storage manager, and it will be used by Strimzi to configure everything, and then by Kafka, of course, for offloading and using the tier storage feature, so moving the data in the corresponding storage that is used by this, the remote storage manager. The support that we have today is mostly about custom implementation. This is why you saw on the previous slide the type of the tier storage is custom. So it means that you can bring your own implementation, and there is no kind of strict API for the several providers that you can use for the storage. We are exploring in Strimzi this Haven open source plugin, which is supporting several storage, as you can see here, Amazon S3, GCS, and Azure Blob storage. But of course, you can write your own if you need something different, and then, using the tier storage field within the Kafka custom resource to set all the configuration. But the plan is, as you can see here, when, so tier storage is finally GA since Kafka 3.9, it's now production ready. It was not, so it was in early access in 3.6. Now that it's GA production ready, we are thinking as a future step to have a more kind of strongly typed API where we have a better support for the several storage that are available, that we have out there, instead of having this kind of custom support. The next feature is about auto rebalancing on cluster scaling. So as mentioned before, there is a cruise control integration with Strimzi. You can use cruise control in order to run your rebalancing in the cluster. But the interface that you have today is by using a specific custom resource. It's called Kafka Rebalance. So instead of talking with the HTTP REST API exposed by cruise control in order to get the proposal, to ask to cruise control to run the rebalancing, still again, Kubernetes way, you are writing your Kafka rebalance custom resource where you can specify the goals that you want to achieve with the rebalancing, but it's manual, right? And if, for example, you want to do something like scaling of your cluster, so you are scaling up, you are adding more brokers. These brokers are not getting partitions from the existing topic. They are getting partitions and replicas only for the newly created topic. What you have to do after scaling up your cluster, you have to run a rebalancing, so creating manually your Kafka rebalance, and cruise control will move partitions, the existing one from the brokers to the new ones. The same if you want to scale down. If you want to scale down, you cannot just scale down if the brokers that you want to remove are hosting partitions, because you could have problem like partitions offline and under the minus in-sync replicas and so on. So you don't have the data accessible this way. So you first need to make these brokers empty, so moving the partitions off, and you can do that by running a rebalancing. And then when the brokers are empty, you can scale down. Of course, it sounds today as a kind of two manual steps process, right? So first scale up and then moving partition, or first moving partition and then scale down. With the auto rebalancing that you can configure within the Kafka custom resource, you can just deal with scaling. So you just increase the number of replicas of your brokers, or just scale down and so decrease the number of replicas. And then the operator will take care of running the scale up and then running the rebalancing for you, or on the other way around, first running the rebalancing and then running the scale down. Of course, there is a kind of templating here because you are not writing your Kafka rebalance, but you want still specify the goals that you want to achieve in rebalancing. So you can specify a Kafka rebalance as a template and specifying the goals, but information like the so-called mode that cruise control has to use, so add brokers or remove brokers, or what are the brokers' IDs that are going to be added or removed, it's something that the operator can set for you, because the operator knows that you are adding these brokers or removing these ones. So it's just a matter of scaling up and scaling down, and the rebalancing will happen automatically for you. So these are the three main things that we have today in the latest version of Strimzi: KRaft, tier storage, and auto rebalancing or scaling. What's next? These are the 5 main things that we are exploring today. So the first one is about improving the certificate management. So within Strimzi today, everything is secured by default. So there is TLS connection between all the components across the cluster. The Strimzi operator by default creates a CA root certificate, which is going to use to sign the server certificates for all your components, or the user can bring their own certificate to be put inside a secret in order to be compliant with what Strimzi is expected, right? There is no integration with the kind of certificate management system like Cert Manager. So there was a proposal, it was approved, and the implementation is going on by one other of our core maintainers, Kate Stanley. And yeah, we are adding this better integration with Cert Manager. So you can specify to use within your custom resource that you want to use a Cert Manager, providing several information. Cert Manager will going to create the end entity certificates for you, and then the operator will take care of bringing the certificate and use them for your cluster. So the user can kind of set up their own PKI in order to handle the certificates the way they want. The implementation will be pluggable in the sense that we would like to have in the future support for other certificate management systems. But the first one will be Cert Manager, so we are focusing on that. The next thing is Kafka cluster self-healing. So again, cruise control, I already mentioned. Kafka rebalance for running manual rebalancing or the auto rebalancing, which works just for scaling up or down. But cruise control provides another feature, the anomaly detection. It's able to detect some anomalies that you have in the cluster, like broker failures, disk failures, or goal anomaly, so goal violation, topic anomaly. And it's also able not just sending notifications that you can define, like, I don't know, using Slack or some other, or your even custom implementation for the notifier, but it's also able to fix the issue for you. And of course, in this case, so we would like to integrate this self-healing feature that cruise control provides. Of course, in this case, there are some challenges, right? The user is not controlling the process because it's cruise control starting at some point to fix the cluster. There is actually nothing that you can do, but we would like at least providing a way for the user to know what's happening, right? So an idea could be just sending some Kubernetes events so that you can monitoring and say, okay, cruise control started this kind of fix because this anomaly was happening. This proposal here, a Strimzi proposal, is still under discussion. So if you are interested to this future, I would suggest you to jump into discussion, providing feedback, and see what are the things that works for you, and do you think that will be better for the Strimzi project. Another big step will be moving to V1 APIs and finally releasing Strimzi 1. So for a long time, Strimzi was a 0 dot something, like. And it doesn't mean that Strimzi is not production ready. We now have a lot of companies and users in the community using Strimzi since years in production. It was just our decision to have Strimzi 1.0 out only when Zookeeper was going to be removed. And it took a long time, right? So now that we have Kafka 4, a Strimzi 0.46 coming, it will be the time to start thinking about finally Strimzi 1. Also, together with, of course, moving to the V1 API, because today we have a V1 Beta 2, and of course the process will not that simple. So I mean, we are going to remove some already deprecated fields. Maybe we are rethinking something based on the lessons that we learned in terms of the API that we designed since the beginning. We will have several Strimzi releases where we are going to support both V1 and V1 Beta 2 API, and then at some point we'll release Strimzi 1 with just the API V1. The next feature will be gateway API support. So today with Strimzi, if you want to expose your Kafka cluster outside of the Kubernetes cluster, you can use ingress, but you know ingress depends also on the controller implementation for the ingress, like NGX and so on. You can use node ports, or you can use also routes if you are running on OpenShift, for example. But there is this gateway API, this framework that is pretty mature now, and so the goal of the gateway API is kind of replacing Ingress, and we would like to have a built-in integration of gateway API within Strimzi. So today you can already use the gateway API. There is also a blog post on the Strimzi website by a community user. And it was mostly about setting up everything manually. So you have to set up the several custom resources you need for the gateway, set up the gateway, the TLS route, and so on. What we want to have is more built-in integration in Strimzi. So you can specify in Strimzi, the Kafka custom resource, you have the listeners for exposing your cluster. You won't like just to set up that you want the gateway API, and Strimzi will set up everything for you. So it's something that we have to start to think about. The last one is about stretch cluster. So stretch cluster is about running a Kafka cluster stretched across several Kubernetes clusters. There was some request from several community users, and actually there is a proposal which is written by some users from the community, still under discussion. Of course, there are a lot of challenges here because Kafka is very sensitive to latency. So we don't see this working on Kubernetes cluster running in different continents, for example, because the latency will be too high. But maybe in metropolitan area network and so on, and it simplifies, for example, the migration of the Kafka cluster between Kubernetes clusters. So again, a lot of challenges. The discussion is going on. There is the proposal. If you think that it's an interesting thing, yeah, jump into it. Regarding the future, it's not just about features. So as I mentioned, we have this list of new features coming and under discussion. There is the StrimziCon. StrimziCon is a virtual conference. We already had the first edition last year. I can say that it was a success from my point of view. We had kind of 300 people joining, more or less. It's virtual, it's free. The agenda will be out soon, maybe in the next week. And you will see sessions around Strimzi core internals, so how things work internally in Strimzi. Or, for example, use cases or scenarios about users or companies using Strimzi in production. Or, for example, how Strimzi can work with other CNCF projects. So what are the kind of integrations that you have with Strimzi? Yeah, so this is a link where you can find all the information for join the project. Joining the project as any open source project could be about just jumping into the Slack channel and asking for questions if you are in troubles with using Strimzi somehow, so finding help from the community, or for example raising bugs on GitHub, and if you want you can even contribute to fix a bug, it will be great. Or implementing features, proposing features. So we have this process like in Kafka, the Kafka improvement proposal, we have the Strimzi improvement proposal. So if there is something that has a big impact on the project, you can start a proposal and so start a discussion about I would like to have this, what do you think, or the community would think about that. Or, for example, even just fixing the documentation. So you are going through the documentation, following the several steps for configuring stuff, and you see that something is not clear or doesn't work the way that it should work. Yeah, these are all the references, and it would be great to have someone new using maybe Strimzi and engaging the community. So that's all. Thank you. We have 1 minute, I think, if there are any questions. Otherwise, we'll be around and you can just... there is a mic coming, so...
Is there an alternative for Mirror Maker? Because you mentioned that it was going to be dropped.
Sorry, an alternative for?
Mirror Maker?
Mirror Maker.
For Mirror Maker? No.
Mirror Maker 2. Mirror Maker.
So we deprecated Mirror Maker 1, Mirror Maker 2. So you can still use that. It's an old version of Mirror Maker we're deprecating.
Any chance that you can go over the differences between Mirror Maker 1 and 2? If any chance that you can go over the differences real quick between Mirror Maker 1 and 2?
difference between
The breaking changes?
1 and 2.
Between 1 and 2, between
Yeah.
Exactly.
Mirror Maker. So Mirror Maker 2 is totally different. It's based on Kafka Connect.
Come again?
Mirror Maker 2 is totally different from Mirror Maker 1. It's using Kafka Connect underneath.
I see.
So it's a totally different thing, right?
Yeah, it was rewritten to make it more efficient
Yeah.
and performant. So
While Mirror Maker
very
1 was still based on Kafka clients and underneath. So it's running this Kafka Connect, which is another Kafka framework within the Kafka ecosystem about moving data across several systems. So for example, from a database to, I don't know, some other database, you can go through Kafka, like a log.
So for example, if I'm deploying a Mirror Maker 2, I'll also see in the same namespace Kafka Connect?
You will see Mirror Maker 2, but underneath it will run Kafka Connect. So yes, you cannot interact with Mirror Maker 2 like it was Kafka Connect.
We got to plan the migration as soon as possible, yeah.
Yeah, and that's the tool for running this, for running migration.
Cool.
Okay, thank you.
Yeah.